Okay, in the last video, we came up with this idea that there's actually two ways that triangles can be similar. If their corresponding sides are in proportion, if they make the same fraction, their corresponding sides, or if their corresponding angles are equal, either way, the triangles must be similar. We're going to prove these things, and the proofs do come up on exams. They're kind of important. The first proof is going to look like this. If two triangles have equal angles, are equal angular, then their corresponding sides will be in proportion, and we'd say the triangles are similar. If you ever do that, if you show that because um, if you do that, you show that they're proportional, and you use the reason that you've matched up their angles, you write angle, angle, angle. So if they must be in proportion if they've got the same angles. But the other side is true as well. If two triangles have corresponding sides in proportion, then their angles must be exactly the same. They must have corresponding angles too, and they must be similar. So um, if the two triangles have corresponding sides in proportion, then their angles must be the same. They must pair up, and the triangles are similar. If we use that reason, we have to write sides of a triangle in proportion. Okay, now here's some other stuff here. You know, when we're writing this stuff, if we say we use these three lines like this to show that two triangles are similar, and if we have, say, triangle ABC is similar to triangle DEF, this order is really important. It's super important because this first letter here matches up with the first letter here, and angle A will equal angle D, and the letter in the middle matches up with the letter in the middle here. So angle B equals angle E, and angle C will equal angle F, the angles on the end. Now, not only do their angles match up, but it's real important. Sometimes you don't want to, sometimes you get really confusing looking at a bunch of triangles crossing all over each other, and you're not quite sure what's proportional to what. If you've got triangle ABC is similar to triangle DEF, you can do this for sure. If you take the first two letters here, AB, and then you match them up with the first two letters here between the two angles that are the same, AB over DE will equal these two ones, BC over EF. Just make sure they're matched up the same, as well as AC over DF. Those are your three proportions that must be true. And you can get them from just looking at the letters. Hey, that's real important. If you didn't get that, if the angles match up, that A goes with D, B goes with E, C goes with F, and the sides match up in pairs. AB goes with DE, BC goes with EF, and AC goes with DF, and makes these ratios a proportion that are so important. So make sure you get that straight. The next thing we're going to look at is actually proving these things. But there's one thing when you're proving similarity, if you match up two pairs of angles, the third pair is automatically equal because of angle sum in a triangle. You don't have to keep saying it. If you could just match up two pairs, then you've got that the triangles are similar. We're going to do the proof next. I hope that made sense.